All right, so let's take a look at another problem that we're finding the domain. We're given this a radical square root function. We're asked to find the domain. Anytime we're given an equation, we always think we start out in the exact same way every time. The domain is the set of all real numbers, excluding any values that would cause division by zero. Well, that happens if you, well, it could happen if you have a variable in a denominator, but we don't have a variable in a denominator. So I do not have to worry about division by zero for this function. But I do have a variable that's underneath the square root, and I have to avoid taking the square root of negative numbers. I can take the square root of zero, and I can take the square root of positive numbers. I cannot, within the set of real numbers, take the square root of a negative number. So depending on the value of x will depend upon what the result of this subtraction is. 3 minus 0 is just 3. 3 minus 4 is a negative 1. I have to avoid things like that. I have to make sure that whatever value of x that you plug in, that you're going to get a result that's either 0 or positive. So let's solve this inequality for x. If I subtract 3 from both sides, and now if I divide both sides of this equation by negative 1, or multiply both sides of the equation by negative 1, then I change the sign. But remember, I also have to change the direction of the inequality. So like I say, you don't have to do this, but it may help some people to draw a number line and to zoom in and think about the value of 3. To the left are numbers that are less than 3. To the right are greater. And 3 is going to be in my set, so I represent that on this number line by a solid dot, by shading the number 3. I want to also shade values that are to the left that are less than 3 to the left of 3. So I shade these values. Okay. 4 is not shaded, so I don't want 4 to be in the domain. Let's plug it in anyway and see what we would get. 3 minus 4 is negative 1, and I can't take the square root of negative 1, so I'm glad that's not shaded because it's not supposed to be. It's not in my domain. So let's describe the shaded region using interval notation. The arrow is shaded. That's representing our infinity. Since it's to the left, it's negative infinity. Never make that a bracket. And now here I have to determine on this 3 whether I want to have it a bracket or a parenthesis. And since it's a solid dot, I need to include the number 3. And that's what a bracket indicates by definition, to include that endpoint of 3 in the set. And the set is what we're using as input to this function. It's the domain. All right, so let's go ahead and do the next one on this same video. It's a very similar problem. It has the same square root of 3 minus x, but this time we see that it's in a denominator. So whenever given an equation, we always have these two considerations. Our default answer is the domain is a set of all real numbers, but then we have to think about, is there any value of x that would cause division by 0? Since I have a variable in the denominator, it's very likely that there is some value that could cause division by 0. Well, I can see by inspection that 3 minus 3 is 0, so I need to avoid 3 being in my domain. Now, this 3 minus x, normally with the square root, if it's not in a domain, in a denominator, we set up the inequality greater than or equal to 0. But remember, I've just determined that I don't want x to be 3, so, and that was because I was excluding 0. I want this x minus 3 to be positive. I don't want this to be equal to 0 because it's in a denominator. In other words, I do not want x to be 3. I want x to be strictly bigger than 3. So on a number line, if I just focus in on values that are close to 3, 3 gave me trouble, not because I can take the square root of 0, it's just I couldn't divide by it. And, oh, look what I did. This said 3 minus x, but for some reason I wrote x minus 3. See, when I started to shade bigger, when I started to think 4, I'm thinking 4 can't be in there. So, yeah, this has to be 3 minus x is strictly greater than 0. And we solve it just like we did before. Don't forget, when you multiply both sides by negative 1, to flip the direction of your inequality. So I want values of x that are strictly less than 3. And it makes sense because like 3 minus 2 is 1, but 3 minus 4 is negative 1, and I can't take the square root of negative 1. So I need to write describe this set of numbers that's been shaded using interval notation. Since the arrow is shaded and it's to the left arrow, it's negative infinity all the way up to 3, but this time I don't want a bracket. I want to exclude the number 3, so I have an open parenthesis. So hey, I hope that helps, and I'll talk to you later.